tells us to consider the differential equation dy over dx equals 10 minus 2y. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 0 equals 2. So you can just about guarantee if you see something start like this, it's going to ask you to solve the differential equation and then plug in that initial condition at some point. But usually the first couple parts are not asking you to do that. That's usually the last part of the question if you get a differential equation problem. And there is usually a differential equation FRQ on the exam. Not always, but usually. So the first part says write an equation of the line for the line tangent to the graph of y equals f of x at x equals 0. Use the tangent line to approximate f of 0.5. So this one's not asking us to solve. It's asking us to find the tangent line. The tangent line at 0 is going to use that f of 0 equals 2, which means 0, 2 is your point. It is not necessary to write this here because it is already stated right up here. I like to write it down again to double check that I've got that. I just put in the Pi Day extra credit. Alright, so where are we going to find the slope? dy dx is our derivative, so that is our slope. We're going to put this line right here. We're going to put such that xy equals 0, 2. And then, so when we plug it in, we're actually only plugging the y coordinate in because we only have a y in our expression. So we'd have 10 minus 2 times 2, which is going to give us 6. That is our slope. So our tangent line will be y equals 6 times x minus 0 plus 2. Of course, it's not necessary to put that minus 0 there, but you can if you want. Can you just say that y equals 2 since there's not an x in the equation? Or do you have to put like such that where you have x, y equals 0, 2? Could you say that y equals 2? Probably. In that case, because you're not plugging in the x. If there's an x and a y, you definitely have to write it like I have here. Okay? And then so the last part of this is asking us to approximate. So what do we do to approximate? Just plug it in. So f of 0.5, what do I need to use after this? Squiggly equal sign, our approximate sign. So we'll have 6 times 0.5. I'm not going to write that minus 0 there, but you can if you want. Plus 2. So that is going to give us 3 plus 2, which will be 5. So f of 0.5 is about 5. All right, so now they ask us to find the value of the second derivative at the point 0, 2. And then ask if that's concave up or concave down, give a reason for your answer. So when we're talking about concavity, how do we know if we're concave up or concave down? Second derivative is positive or negative. Right. Second derivative, yes. So our first derivative is 10 minus 2y. You don't have to rewrite that if you don't want to. When you take the derivative of this, you'll get the second derivative equals, what's the derivative of 10 minus 2y? Almost negative 2 dy dx. Because that has a y, you have to put that dy dx there. So, you got a couple options of how you can do this. I would do it this way, d squared y over dx squared, second derivative, such that xy equals 0, 2 is going to equal negative 2 times, what is the derivative at 0, 2? It's 6. We just found it in the earlier part, right? So you'll just get negative 12. The other option for that, if you didn't kind of realize that you already had that from the beginning, from the part ahead of time, you could also write your second derivative like this, negative 2 times 10 minus 2y, like that, because you could plug in the dy dx here, and then you could plug in the xy equals 0, 2. You'll have negative 2 times 10 minus 2 times 2. Also going to give you negative 12. I would prefer that you do the first way. So this is like an extra alternate solution. You don't have to do that. So if you have this, you would stop. But sometimes you may not realize that you actually already know this value from part A. So yeah, so if that doesn't stick out to you, then here's an alternate way that you could solve that. So this is, you wouldn't have to have both of those. Okay, so and then typically for these, this is actually not the last part. It does ask you to do something else after this. But typically for these, the last part is going to be that you got to solve the differential equation. So we've got dy over dx equals 10 minus 2y. All right. So we will multiply both sides by dx because we never want that dx in the denominator. Okay. What do I need to do after this? I'm not going to integrate yet. I need this 2y to be over here, but I can't just move just the 2y. I'm going to divide. I have to divide by that whole expression right there. So this is what it should look like if we separate variables. You're going to get a point for separating those variables in this, usually. Now we need to integrate both sides. The right-hand side is just going to be x plus c. But we don't want to integrate it yet. We've got to do a u du substitution here. And your u would be 10 minus 2y. So what is the du? Negative 2 dy. Just the dy. So we'd have to put a negative 2 right here, which means we'd have to put a negative 1/2 out front. So that would look like this, 1/2 integral of 1 over u du equals the integral of dx. Okay, here. What? No C yet because we have not integrated. And so on this next step, though, we're going to integrate. We're going to get negative 1/2 natural log of the absolute value. You could put the u there. I'm going to go ahead and plug my 10 minus 2y in here. And over on this side, we'll just get x, and there's where I'm going to put my plus c. Notice that even though you could have went ahead and integrated this earlier, I waited so that I integrated both sides at the same time. I'm doing that so that I can just put that plus c on one side. Because technically, as soon as you integrate, you have to have a plus c. And if you integrate this earlier, you would have to have separate plus c's and combine those. Say that again. Because whenever we're integrating this, it's like it's got a 1 right there. So whenever we integrate that with respect to x, when we integrate 1, it's like it's got x to the 0 power right now. We increase its exponent by 1, which gives us x to the first power. Divide out front by 1, so it's just the x. The dx is just telling you what you are integrating, like what you're integrating with respect to. So when you don't have anything there, it's like there's a 1, and when you integrate 1, you'll get whatever variable it is you're integrating with respect to. Does that make sense? And then it's sort of like the dx is replaced by the plus c. So the 1 is replaced by the x, the dx is replaced by the plus c, kind of.
If something's added to c, could it still not just be anything?
Yes. So if well, x is a variable. If it was a number, so if it was like a 7 there, which doesn't happen when you integrate, because if you have a constant, it gets an x put with it. So if you had a number like a plus 7, you could have sort of just absorbed that into the c, and you wouldn't have to write it. But because it's a variable, you have to leave it there. Because c stands for a constant, so it is it's just a number. It could be 7, it could be 5, it could be negative 43. Whereas x is a variable, so those can't be put together. Okay. All right, so we need to get rid of that negative 1/2, so I would multiply both sides by negative 2. So that's going to give me natural log of 10 minus 2y equals negative 2x plus c. Technically, you could distribute that negative 2 to the c, but it's still c, right?
Now you raise it to e.
All right. Good. It's going to cancel over here. I'll get 10 minus 2y equals, what do I get over here?
E to the negative 2x. C, e to
C, e to the negative 2x, because that plus c right there is going to be moved out front as that coefficient.
Now you solve for y.
Now we solve for y, so we'll subtract our 10. The reason that we can just sort of drop those absolute value bars is because that c can be positive or negative, so that sort of takes care of it. Even like right here, I'm dividing both of these by -2, but c divided by -2, I can leave this e to the negative. Oh, sorry. So I have to have c. It is fair game for the midterm, yes.
If you start me out, okay. Why?
Anytime you take the integral of a natural log, you're supposed to have those absolute value bars there. They go away right here because when we do this e to the power on both sides and this c comes out front, that c could be a positive or a negative value, so it kind of, you know, yeah, if you left them off right here, I don't know if they would count off or not, but they are technically supposed to be there. Okay, so we're solved for y now, but we do need to find that c value because it tells us we need the particular solution. So a particular solution doesn't have a c in it anymore. So we're using the point 0, 2. So we'll plug in 2 equals c e to the -2 times 0 plus 5. So we could subtract our 5. So we get -3 equals c e to the 0 power. And then e to the 0 power is just 1. So -3 is our c. Because that's c times 1, which is just c. So you do need to plug that back in. So y equals -3 e to the -2x plus 5. And that would be your answer there.
Would that be like pre-calculus algebra?
No. I mean, this last part right here, solving this, yes, yes. Solving this, yes. This part's definitely calculus.
I know that all that's like calculus.
Yeah. So, like right here, once you plug in the 0 and 2 for your x and y, c should be your only variable left, so c is what you're solving for. You want to find that c. Yes. C is an unknown value, but it has to be a number, like a. Yes.
So with c, is it like if it's multiplied by anything? C's kind of added or subtracted, it's still just c.
Yes, until this last. So Addison has a really good question because we pretty much don't do anything. Guys, quiet. If you already know all this, that's great, but please be quiet so everybody else can hear. Addison had a great question and sort of piggybacked off what Thomas was asking here. So it seems like we don't ever do anything to C, right? Like we didn't really distribute that -2. We didn't divide it. We don't mess with C because it's an unknown value. And that is true until you're plugging your initial condition in. All right. So when you plug in your initial condition, which happens right here, right here's where we plug in that initial condition. So we're plugging in that point. Now you're solving for an exact C value. So you're trying to find exactly what that C value is. So you're treating it like X or Y now. So at this point, if you need to divide by 2, it actually is a variable here. So in this setup, C could be any number. That's what we call our general solution. So solving this differential equation would give you equations that look like this. Y equals some number times e to the -2x plus 5. So C could be anything. It could be 2, it could be 4, it could be -7, it could be 1,000. It could be anything right here. But we want the one solution that goes through this point. And if it goes through that single point, there is only one solution that happens for, and that is going to be whenever, in this case, whenever C equals -3. And this is the stuff that was new yesterday, plugging that initial condition in. So we had done everything up to y equals ce to the negative 2x plus 5 before. The stuff that we started yesterday is finding that using that initial condition. Yes. They usually call it that. I'm trying to think if there's any other phrases they may use. They could tell you something like the particular solution passes through the point 0, 2. They may give you that instead. Okay, questions on C? All right. For part D, it's asking you to do the limit as x approaches infinity of the equation that we just had. So negative 3e to negative 2x plus 5. We can only use L'Hospitals if we get 0 over 0 or infinity over infinity, which is not happening right here. What I would do for this is you have a negative exponent there. So I would do this. I would make this negative 3 over e to the 2x plus 5. So just move that negative exponent down to the bottom, which is going to make it positive. And so we can do these two pieces separately, that they are separated out. So we have to look at this part. I'm going to write this, but you don't have to write it. Limit as x approaches infinity of negative 3 over e to the 2x plus limit as x approaches infinity of 5. Right, so you don't have to write that step, but you can take the limit of those two pieces separately because they're added together. What is the limit as x approaches infinity of negative 3 over e to the 2x? It is 0 because that's bigger on the bottom. You have your bigger exponent on the bottom. What about the limit as x approaches infinity of 5? It is 5, so you will get 5 as your answer. There's no variable there, so it's just a horizontal line. It's just always 5 no matter what. If it was 5x, it would be different. It would be like infinity. If x approaches infinity, that's when you're going to use no equals dc. So if it's bigger on the bottom, it will be 0. If it's bigger on the top, it will be not 1, meaning it's infinity or negative infinity. And then if exponents are the same, you'll divide coefficients. I guess we could make a fourth case, but I don't have a cute rhyme for that. If it's just a constant, it doesn't matter what you're approaching. It could be x approaches 1, x approaches 1,000, x approaches infinity. It doesn't matter. It's just going to be that constant. Okay, questions? All right. Okay, that homework that's on the last page or two of that is going to be due on Monday. Okay, so that is due Monday.
So we don't have any homework or anything.
I'm going to give you one more midterm.
Oh, yeah, that'll be due.
That'll be due tomorrow. Okay, so I'll go ahead and pass this out.
It's like a whole bunch of stuff. It was like that. And I put in the play before. Today's homework? What?
All right. Let's see. What did this use our time? Did anybody have any questions from yesterday?
So, lip tiles.
Yes.
Lip tiles and squeeze, we don't need squeeze there.
No.
So, what is the lip tile?
L'Hopital's says that if you're getting 0 over 0 or infinity over infinity, which in this case you get infinity over infinity, then you can take the derivative of the top and the derivative of the bottom of that fraction.
So it'd be 1 on the bottom?
Yes.
And then e to the, 1 over, okay.
1 over e to the 2x plus 3x times the derivative of that, which is the derivative of e to 2x is e to the 2x, except for you got to multiply it by 2 because the chain rule. And then the derivative of 3x is 3. And so this ends up being Bobo Botno because you got an e to 2x here and an e to 2x here. That's exponents are the same, so you just divide your coefficients. Yes. They're not, because speed does not have direction. So whenever you do...
So that's why the velocity can be positive 1 or negative 1.
Yes. So that's why I set that equal to 1, which I just found on my calculator, and negative 1, which I also found on my calculator. There's not a ton of limits on there, so. Also, the stuff I put over here in green, like the calculator notation, these are hints that I put on there for you guys. On the AP exam, they do not accept calculator notation. So, like, if you don't write down, what I have in red needs to be written down. If you just, instead of saying a prime of 3.4 equals this, if you did dy1 of x, comma x, such that x equals 3.4, they would not give you credit for that because everybody's calculators are different, and it's got to be this over here. This was just a note to help you remember what to type in. Yes. Yes. Yes.
So, when you have like the limit as x approaches 1 of just g of x, that's
Yes.
just like looking at the graph, like
Yes.
where it approaches.
Yes.
But if you have f of like x plus or multiplied or whatever, you have something else in the parentheses, do you just plug in whatever x is approaching?
I'm going to be honest, Addison. I think so, but I don't like this question. Because at first I thought they were all true. This is what I came up with, but my key only gives me the correct answer. There's no explanation on it. So I know C is the answer because the key tells me that C is the answer for the... I mean, I made this one up, but it's similar to one that you might see tomorrow. So, like, A and B you should pretty easily be able to tell are true. Here, whenever you do these two limits separately, you're definitely going to get values for those, right? Because you get, like, limit as x approaches 1 of f is clearly negative 3 because it's defined there. And then g of 2 is also clearly defined. So that one we know exists. This one, I feel like that f of 2 should not exist, but it tells me that it does. So this is what I came up with about it. So I think that's the reason. But I might need to ask AP Calculus. I don't know if I can ask about this one because I'm afraid to put it on Facebook because it is a secured exam question. I mean, I made up this question, but the one I'm copying is a secured exam question, so I'm afraid to post it on Facebook because you're not allowed to post those questions on Facebook. I have access to all of them, and I can give them to you in class. And I can give them to you on paper in class or give them to you on AP Classroom with the secured browser, but I'm not supposed to let them leave the room. So, and certainly not supposed to post because they want there to be like several secured exams that you can't find all the answers to online. And it's I'm not saying you can never find the answers to them online, but it's a lot harder than like the release stuff that they put out there. All you gotta do is Google like the first 10 words of the problem and you can easily find it. So we may never know 100%, but if you were to see something like this tomorrow, this logic will hold up. And I think you may see something like this tomorrow.
So you made a velocity. I made like a super good actual value. Good.
So confident. Yes.
Velocity and acceleration are having the same sign. They cancel out.
You don't want to say that they cancel out, but yes. You can. All you need to say is if they have the same sign, or so you could say they're both negative or both positive. In this case, they're both negative. Then you know it's speeding up.
So they're both negative, it's positive. And if they're both positive, it's also positive.
Right. But if they have different signs, then you're slowing down. Okay. All right. Other questions? All right. So your assignment for tonight is to do this third review that hopefully I have not messed up on the key, but I have posted the key for you. Hopefully it'll work. It is all calculator active. The multiple choice are ones you would definitely have the calculator for. On the free response, you probably would not have the calculator for this if it was a real FRQ, but I made it up, so I made up one that was too hard to do without the calculator because it crossed the x-axis at that weird point. So I just made it calculator active. But I would try to do most of it without the calculator. There. Antiderivative is the same as an integral. Yeah. All right. We have 7 minutes, so everybody do a problem. Don't put it away. Everybody do a problem. Whichever one you want to do. On the third one I just gave you. Yes. Alright, so what you want to do on that one is you want to integrate, because you've got P equals 1 and P equals 4. Because if you do it like this, that one's too complicated for the calculator to do, and even if it would do it, it would plus the right. So what we want to do is we want to do integral from, we got 4 and 1, so I would do the integral from 1 to 4 of all of that stuff, which is going to equal P 4 minus P over 3. So whenever you do that, so to do that, you'll just put like your comma 1, comma 4 there at the end. So you get a
instead of the X.
No, X still needs to be there. So after the X, but before the last parentheses, you'll put a comma. So this is going to give you some decimal right here, which we'll get in a second, and that'll take a while. It tells you that P of 4 is 9, and that's, this is what we're trying to find right here. So what number does it give you here?
9.1012.
So
negative
yes. Alright, does anybody else have those test corrections? Because I do not have many test corrections here. Yes, I do. Have them from Alfredo, Jack, Chandler, Margaret, and Addison. That's all I've got right now. Okay. Let me take that. I'll take that. And Daniel got yours. Emerson, I have yours. Laura and Logan. test corrections. They go in the test section, so you need to make sure you have those. You may use a late work pass and bring them to me tomorrow. If you're really desperate, 2 late work passes if you bring it to me Friday. I cannot take it any later than Friday because my grades are due Monday.
Also,
I have to get all my grades done and we don't have a work day. No. 10's maximum.
I didn't imagine because like if we make a video, we'll get extra.
I got to look like you know, and I was like,
Video with us.
tomorrow is free response.
Yes, we're doing free response tomorrow.
And it'll just be what, like half calculator, half
There are 5 questions, except for one of the 5. There's one part that you won't do because we haven't done it yet. So there's 6 questions in the actual test. There's 1 out.
So this is just like straight from
Oh yes. I took 1 question off completely because we can't do it, and there's 1 part I took off and another one we can't do yet. But otherwise, you.
I need to go to the lobby.